So again, as I mentioned before, we can take water levels to work out what's happening with how water wants to move through the landscape. We can also take chemistry samples and send that off to a lab to figure out the dissolved salt load. We can also do analysis on the isotopes in the water molecule, so oxygen 18 and hydrogen 2 predominantly, to try to track how water is actually moving through the environment. And we can also use radiogenic isotopes, so those are isotopes that decay over time, for us to then try to put a time frame upon which processes are occurring. So throughout these processes, you actually need to continually monitor. So when we plug all this information into our models and it projects a certain scenario or projects a certain way that the system is going to adapt to having groundwater extracted out of these coal seams, we still need to keep collecting information through monitoring to actually see is what is actually happening in the environment what we thought was happening through these models. And if it is, all hunky-dory. If it isn't, then we need to step back, have a look at the data, reassess how does this new data fit in with the data that I had previously, and what does that now mean for how the models need to be developed to project potential behaviour in the groundwater systems, adapt what we're doing and then implement that new framework. Monitoring, review, adapt, implement. And this is a cyclic process that keeps happening all the time, not only in coal seam gas, but pretty much any activity that requires any type of environmental disturbance. And it really does require not only the proponents who want to extract the coal seam gas for use, but the communities, the researchers and the regulators to all come together to build up this data set, to continually review this data set and to continually implement changes and adaptations as we find out more about how not only the system operated prior to coal seam gas extraction, but how it is behaving in response to that disturbance.